Thanks for coming. And now I'm going to talk about Android and Docker and how Docker is going to help Android. My name is Jing, and I'm working for Viacom. Sorry, just a second. So Viacom is a company who owns lots of brands like MTV, BET, Comedy Central, Paramount Pictures, and also Nickelodeon. So tons of characters and movies. So let's talk about how the story gets started. Was many years ago, long time ago, was back to 2008, the year where Android get born. So it's already 9 years ago. And then back to the year of 2013, there came Docker. So let's see how they can help each other and play with each other. So actually, where does the problem start? And why I want to talk about Docker and why we want to use Docker. And so this is a tool called Infern. It's made by Facebook. It's another static analysis tool to detect the bugs for Java and something else. And so Facebook, just for the ease of setting up making the installation easier and also deploy of the running easier, so they just wrap everything into the Android SDK Docker image. But the Android SDK Docker image just contains basic Docker SDKs, just like 200 or 100 something megabytes. And that should be fun, but in fact, when I run it, it fails because it fails running the Android SDK update. You have to get the SDK update to download some SDK dependencies for your project. And why? The reason is because of the default file system of Docker is using a thing called AUFS. And that one doesn't support some of the file operations. For example, during your upgrading of the Android SDK, it will frequently doing some file operations, just like hard link moving, which is not supported by AUFS. That's why it fails. And basically, it just lead to the result that I couldn't compile my Android project on the Docker container. But you probably want to know that who cares, because I don't want to use Infern, I don't want to use Docker, I just want to compile my Android project. And so here is an Android developer, and one day he just get a brand new fancy laptop. So he just become happy, and he would like to put a bunch of the Android project to the laptop and try to play with them. And it happens. Couldn't find Git, couldn't find Java, couldn't find Android SDK, Gradle, this and that. Now he's super frustrated. So not only for one machine, it's also pain in the ass when you have to provision tons of different machines, for example, CI. And I believe that most of your company not only produce the Android applications, but also some other mobile products, just like iOS applications. And you know that iOS application, it has to run on macOS. And you probably have laid around a bunch of the Mac minis in your company to serve as a CI. But before we talk about Docker, and there is actually many options like containerization or virtualization. Let's talk about what is the difference between them. As you can see here, the base layer is infrastructure, which is your bare metal, your physical machine. And then you have your host OS running on top of the infrastructure. And the difference start from here. On the right side is Docker, And Docker uses the technology namespace and control groups to share all of the resources. And on the left side, the virtualization, it has the sorry, just a second. It has the overhead hypervisor, which try to virtualize a different VM on top of it. And as you can see here, the layer of virtualization is more a bit overhead, but it provides better isolations. But on the right side, Docker is more lightweight. So each of the container, they share resources, but they couldn't isolate the resources well as good as virtualization. So why do we want to choose Docker instead of like Vagrant? Here is a comparison. As I said before, Docker, the isolation solution is a bit low, but do we really care about it? Not really. And the supported OS, Docker only support Linux due to the implementation. And Vagrant supports all kinds of OS like Mac OS, Windows, Linux, whatever you want. And now it comes to the pros of Docker, the boot time and stop time, and also the size. The boot time and stop time of Docker is pretty low, like just in seconds. And on the contrary, Vagrant takes minutes to launch, also for stopping. And in terms of the size, Docker image is only like a few hundred megabytes, and Vagrant is over gigabytes. And why that is important? Because I mean, if you want to use Docker for your CI build job probably runs only for minutes. And if you take the boot time into account, then the Vagrant will just significantly add up the whole build time to just slow down the performance of the build job. But on the other hand, Docker wouldn't. So let's just have a brief introduction of the Docker terminologies. The first thing is images versus container. And by the way, I just want to ask how many of you have ever tried to spin up some Docker service by your own and play around with it? Please raise your hand. Cool. So, and many of you also haven't started with Docker, but you are Android developers, so I guess it's a good start to try it out and to understand why you need that, why it could bring you benefits. So image is just like, in the Java terms, it's just like a class definition. And container is like an object. So you can just have one image serve your needs, and you can have a bunch of containers initialized from that image. And what is build and pull? Build is when you have a Docker file locally, you want to build it. And pull is like when you have a Docker image on the server side, like on the remote registry, like Docker Hub, you can just pull it, and then you have it locally. You don't have to build on your own. I think that's enough. Just let's see the next one. Dockerfile best practice, just like code. Dockerfile is also quite sensitive. You need to pay attention to that. The first thing is single responsibility. When build Docker images, you should be careful that you shouldn't involve too many packages, libraries, or different things into one image, but instead you should keep it small, keep it just single responsibility. And if you want to if you want to orchestration, then you should really think about Docker Compose, that you can combine different services together. Just like when you want to use Sona to check your code quality, you can just have two Docker images two Docker containers. One is performing all of these SONA checks, and the other one, of course, the SONA checks has to be persisted into some database, and then you have to have another Docker container, which probably could be a MySQL container, and you just orchestrate them together to serve the need. And the second rule is you should try to minimize the number of the layers. Docker is about layers. It consists of layers. So each single layer is actually an intermediate image. So it's just built on top of each layer, and it supports also caching. Just like when you have some base layers, which is not changed, and you can, for the next time when you build it, it will just directly build starting from the next layer on top of it. And also size matters. You should use what you have. Because Docker is not really like a typical file system, but it's more like a Git file system. It's always tracking the changes. So if you try to simply install and uninstall some libraries, just like a wget or curl, to download something for yourself, then you want to install from one line and then uninstall from the other line, it will just also add up this image size because it's tracking all of the file changes. It doesn't matter if you install and remove it later. And because we have talked about minimum the number of layers and reduce the size of the image. So you probably want to also combine lots of different steps into one step, but that will also break the readability. Now let's just have a brief look at the Android SDK Dockerfile. So this is Android SDK Dockerfile. Can you see that? The first line is talking about which of the base image you want to use. And here, just like normally you would like choose Ubuntu. And forget about this useless things. And then this layer is talking about, and you can see that I just, for the readability, I break the step or the layer into different lines. And here I try to add the support for i386 architectures and also install Java. Of course, you need Java and some other essential tools. And Qt here is for the emulator. And the next layer, I try to download Gradle. Of course, you have your own Gradle wrapper, your own Gradle version, but for this one, I just want to prepare the Gradle beforehand to make your life easier. And the third one is the most important one. It's download the Android SDK from Android SDK website. And all of the keywords like inf is setting the environment to run. It's like running a batch script. It's all Dockerfile keyword. And here I just try to set the environment variables. And here is the must-have step that you have to set the accept the license. And also by using this Android SDK Docker image, by default you also accept all of the Android license. And this layer is about add the functionality of enabling SSH server so that later you can SSH to the Docker container if you want to have it long running and also use it as a CI node. Yeah, that's basically it. Now let's back to the slide. Yeah, so we haven't talked about the solution for SDK update. How was it get solved? So later on, I tried different approaches. I found the solution is like, because Docker allows you to persist the data or mount the local volume, the host volume, to Docker container. So I tried to mount the SDK volume to the container, and the problem solved. You don't have to use different driver like BTRFS instead of AUFS. And what is the benefit? The first thing is this solved the problem, is support SDK update. And the second one is, as you've seen from the Dockerfile, it only downloads the basic minimum Docker the Android SDK image, Android SDK package, which is only 200 megabytes. And it's just keeping the Docker image small, but also give you the flexibility that you can just install whatever SDK you need on your own demand. And the third benefit is all of the SDK data is persisted on your host machine. You can just mount it for the next time and save your download time. And also you can share it across different machines, different containers. You don't have to download it again and again. It's cached. Yeah, it's already talked. And at the last, it's very easy to maintain, because it's just one option mount when launching the Docker container. Yeah, I have talked about this Docker image also support SSH. And when building SSH, we have three different things to pay attention to. The first thing is, because I'm living in Germany, and my German is not quite well, and also, I mean, probably most of you have an international team and you have international co-workers, and they do care. They might have problems reading your own country's language. That's why for building the SSH server, I try to use the English as a standard language for the SSH server. And the next one is setting up the environment variables. That really matters, because you have to interact with the Android commands a lot of times, like Android SDK manager, ADB, this and that. And when setting up the SSH server, it automatically exposes all of the local environment variables to the SSH client. So you have to set it up. And the last thing is authorization. You can just choose to build the Docker image locally, and you can include all of your SSH keys inside these authorized keys. But you can also mount them later, copy them later to the container, and just use the standard one. Yes. Why we care about the environment variables? Because, I mean, for CI, probably most of you use Jenkins. And Jenkins, when dealing with the environment variables, I have seen that tons of times that people have problems of setting up the environment variables, or troubleshooting the environment variables, because there are tons of different places to set it up. Like global level, you can configure the system and set the system environment variables. And secondly, you can set it up on the node level. And third, per individual job, you can also have a different environment variable to override the previous ones. That's why I try to really minimize the problems and only set it up in the Docker container. We haven't talked about NFS. But why do we want to use NFS? NFS stands for Network File System. It is really good because we can just save and persist all of the Android SDKs, the large Android SDKs, into one NFS and share it across all different different Docker containers. So here's a benchmark. I try to run the bare metal machine without Docker installed and just purely Android SDK and Java environment and Gradle as well. And for running just like a Gradle check, it takes about 40 seconds. Pretty good. And this one is about using Docker plus Android SDK on the host, so which means on the same machine. And the performance is as good as the bare metal, just like 1 second difference. And the third one is using Docker, but host the SDK in the NFS. And you can see that it slightly increased the build time or the Gradle job time for about 3 seconds. Not really a big deal. And the fourth one is about when you have multiple host machines and each of them run Docker, but all of them try to access the same NFS and mount the same NFS Docker SDK, Android SDK to the Docker containers. And you can see that the performance is not really bad. The first machine, the performance is even better than the bare metal machine. And the next one, I don't know for what reason, it slightly increased the time, but still it's not a big deal, just a few seconds. But this one tells that there wouldn't be a problem when you try to share the Android SDK on the NFS to different machines. And I have checked in the real life that most of the Android teams, they have a bunch of the Android developers, but in the same time could be only 3 to 5 at most Android jobs running on the CI. So that wouldn't cause any problem to the performance. And there's another performance comparison. So I tried with Docker and with the Android SDK mounted from host to container. And the other one is I tried a few of the other online CI solutions. I wouldn't tell you the name, just try to make it anonymous. So the example is like 2 build types, debug and release, and about 107 unit tests, and in total would be 214, and also with 2 UI tests additionally. And you can see that with Docker, it's only about 6 minutes, and it was tested on my crappy MacBook. And the other CI solutions, it takes from averagely from 10 minutes to 20 something minutes without optimization. And to prove it, I actually have a short video. So you can see that this one is an online CI service, and this one is an online CI solution. And on the bottom side, it's my local Docker container, and it runs, and this one already finished, the container one. And the top 2 are still building. And now on the left side, it also finishes. And on the right side, it's still waiting for the emulator. So what I want to say is the container is actually a pretty good choice. But I haven't talked about, can we get any better? Because I mean, on the previous slide, 6 minutes is still minutes. Yes, of course, we can get it better. Gradle distribution, this is the most recent ones. You can see that in your Gradle wrapper configuration, by default, it always tries to download the all. And in terms of the size, it's always like around 90 megabytes. It depends on your network, but the download will definitely take a while. And any better, Gradle caches. Depends on your project. If your project has lots of libraries to download, this one saves time as well. Yeah, time is money. And the Gradle caches is normally saved in your user folder, Gradle caches. We just need to persist it and mount it back to the Docker container. Yeah, it's time to show the picture again from XKCD, the classic one. I have encountered tons of times when building a job, the most significant time is spending on the downloading dependencies. The actual build time is actually nothing. So the solution for the first one is, I have actually set up a Gradle distribution mirror server. So you don't have to download the Gradle or modify the Gradle wrappers, but you can just spin up the Gradle distribution mirror server and set up the SSL certificate according to what is written here. Then add the last thing. You have to modify the host file to point your www.gradle.com to your local Gradle distribution mirror server. And how about Android devices? Actually, we have few of the options. The first one is ARM emulator. It's running on inside the Docker, but it is slow. And the second one is USB. Docker supports accessing the USB from the Docker container, to the host machine. But it needs privilege mode, and also currently it only supports Linux. And the third one is Wi-Fi. You can access your Wi-Fi. You can access your Android devices by Wi-Fi, like ADB. And the fourth one is my favorite one. Use Gemotion Cloud. You don't have to host the service by your own. You consume it, and it's fast because it's not ARM-based. And yeah, the pitfalls and restrictions. As I said before, emulator is slow, and here is the benchmark. The ARM emulator for running like 2 UI tests, the average time is about 2 minutes. And for Gemotion, it takes only about 25 seconds. And USB device, it works fine on Linux, but you have to also bother with the thing that you have to plug the device off and then plug it in again to fire up the trust device dialog. And the last thing is about Docker daemon memory limit. You have to configure it. And actually using Docker, I get a few of the benefits. Is review the machine-dependent problems. I just want to ask you, can you guys guess what kind of machine-dependent problem could it happen? Okay, I'm going to show it. The first one is, of course, encoding problem. Just like this one, the expected value was this, but the actual value was that, because the file saved on the file system is not really UTF-8. And also time zone problems, because Docker uses one time zone and your hard-coded time zone is different than Docker's. And the third one is about file and path. Why it matters? Because I guess sometimes you have to use the JUnit file, temp file, and that one, the file list file, the returned order is not the same. Yeah, the final stage, live demo, or it didn't happen. So I'm just going to show quickly that I have this kind of images, and I have no Docker container running for the moment. So we just start with Jenkins first. It takes a while to boot up. Now we try to start Gradle. Now there are 3 different services running in the background. The first one is Gradle server, and this, as you can see here, this is a real one, and this is my local host. And I only have kept a few of them, the latest ones. And here's the Android SDK Docker container, and there is Jenkins. Jenkins. And we can just also SSH to I just need to copy the proper key there. Now it's copied. Yeah, it's logged in. And we can prove that the Gradle server is the local mirror server. Cat distributions. And you can see that the last one grabbed from the server is 4.0.1, which is exactly the same version here. So it's already set it up within command. And now we should go here and create a quick job. Before that, I can show you that in the Manage Jenkins, you can set you should go to Manage a Node and create a node. I'm not sure this one is still the right one. Give a name and give a tag. Normally I give Android, and the remote directory. Remote root directory is mandatory where you want to download the workspace. And I just want to execute the job which matches the label. And I want to launch this slave via SSH because I already configured the SSH. And I have a SSH key there. Save. And now I just need to configure the job. New item, pipeline, Android, Docker demo. OK. Now we just need to choose pipeline script from SCM and use Git and give the repository URL. I'm just going to find my own and that's it. Now we can have a quick build to see if it works or not. Good luck. Seems like fun. But anyway, as you can see that from my setup, it's just like you use a bunch of the commands, which means that you can automate that on anywhere or just tell your DevOps guys to help you with that command. And you can set up the Docker container, and then you can configure your Jenkins, use that node, or just provision a node on demand, and then just start a job. It takes less than a few minutes. So it's just like feasible and doable. Everyone can just start with Docker and build their own CI service. And you can see here it's just fast. And in theory, I think I should, if I didn't do it wrong, I should have already mounted the Gradle cache. Yeah, just a second. Just 1 second. Yeah, I think it's almost done. Unit test. And let's get back later. Anyway, what else for mobile? Using Docker, there are 2 other benefits. The first thing is we can because for your integration test, you have to talk with the live API. That is flaky, or sometimes it's just dumb. And with Docker, you can just host your API on the Docker and run the Docker container on the same CI that you run the mobile test. So it will just simply talking with the local host instead of talking with live API or sandbox API or staging API. It's lightning fast. I remember I saw this brilliant idea from someone else on some conference, but I forgot which one that is. And the next one is now it's a trend to use serverless. And just like you have Kotlin, you have Swift, and you can just write your API test clients in these two languages and just drop that into any of the container and fire the test. Yeah, last but not least, so our company is still hiring, and in both Warsaw and Berlin for Android developers, mobile developers, and all kinds of developers. If you are interested, or if you have any friends, you can just try to apply there. And last, if you have any questions, or if you are interested in using Docker, just drop me a line on either Twitter or GitHub. I'll be at your service. And just back to there. Yep, it's successful. And as you see, that only takes about less than 2 minutes. And it's brilliant. Why not choosing it? That's all. Thank you.
Yeah, I think we do not have time for questions because Ivan will start very soon. So yeah, like 2 minutes and we will start another topic, the last one. Yeah, okay.
Sorry.